Few people have asked me in my email. You can always email me at any time you want. My email's in the description. Can we have a primer for exponents, also known as powers, also known as indices, also known as probably a few other things? And the answer is, of course, yes. We can always do a recap, and I'll always endeavour to answer any question you have. So the first rule is the rule of multiplying powers. A to the power of m times a to the power of n equals a to the power of m plus n. As long as the base is the same, we're fine. So x to the power of 4 times x to the power of 2 is going to be x to the power of 6. As a little proof, x to the power of 4 is x times x times x times x times x squared is x times x. And if we count up the x's, 1, 2, 3, 4, 5, 6 of them. Okay, should know that one. Complicated a little bit when it has coefficients. So 3x cubed times 4x to the power of 5. We're going to multiply the coefficients. So 3 times 4 is 12, and then we're going to add the exponents. 3 plus 5 is 8. I don't know why I put a bracket there, and that's that done. So multiply the coefficients. And add the exponents. Okay. Well, multiplying is the opposite of dividing, and adding is the opposite of subtracting. So when we multiply two things together, as long as they have the same base, we add them, but when we divide, we subtract. So a to the power of m divided by a to the power of n is a to the power of m minus n, or a over a to the power of m over a to the power of n. The line there means divide by. We do exactly the same thing. So for 4x to the power of 7 divided by 2x to the power of 3. What's that going to equal? Well, before we multiplied coefficients when we multiply them together, and now we're going to divide the coefficients, the top by the bottom. 4 over 2, which I hope you guess is 2. There's no need for that. X 7 minus 3 is x to the power of 4. Okay, let's say we've got 27 x to the power of 10 over 3 x to the power of 8. That's a 10, that's an 8. So 27 over 3 is 9. And keep it on the top line if you can. X, now 10 minus 8 is squared, and we're done. That's it. That's all that one is. There are a couple of slightly tougher examples a wee bit later on. Hey, raising something which is already a power into another power is exactly the same as this. So a to the m, all to the power of n is am times n, not plus n, times n. So say w to the power of 4, and we raise that to the power of 3. Well, that's going to be w to the power of 12. We really want to look at it. It's going to be w to the power of 4 times w to the power of 4 times w to the power of 4. And when we multiply, we add 4, 8, 12. What would happen if there was a coefficient, say 3x squared to the power of 3? In that case, we have to raise the exponent. Imagine that this is a variable though, and imagine that there is a 1 there, which there is anyway, but we don't bother putting it. Well, it's therefore going to be 3 to the power of 1 times 3, which is 3, x to the power of 2 times 3 is 6, and 3 times 3 times 3 is 27, x to the power of 6. You should be very familiar with this one as well. Again, this is just a recap. A to the power of negative m is the same as 1 over a to the m, where it loses that negative sign. So in other words, 3 to the power of negative 2 is going to be the same as 1 over 3 to the positive 2. And just for completeness, if we had 1 over a to the minus 4, that's going to be the same as a to the positive 4 over 1. So as long as that's a really, really bad it's a terrible 4, that's better. That makes a lot more sense. So if the exponent goes across the fraction line, it will either lose or gain a negative sign. This one you should have definitely seen. This is using fractions and exponents to make them a radical sign. What do I mean by that? Well, I mean that a to the power of m over n is the same as the nth root of a to the power of m, which is the same as the nth root to that power, all to the power of m. Which sounds amazing, but it actually does work. This one here is useful. We can use, instead of square root of x, we could have x to the power of half, x to the power of 0.5. Same thing. Okay, let's prove this one then. So let's find, let's find 3, and let's square it, and then find the square root. You should be saying that that is 3. You'll be right. Fair enough? Okay. Let's do another one. Let's say we want to find the fourth root of 1028. Now don't know what that is off the top of my head. I suspect I do know. But how are we going to do it on our calculator? There is this kind of button shift, but I don't know how to do that one. So a quick way of doing it is 1028 to the power of 1 over 4, which is that, which is the fourth root. Okay. Same thing again. If we do 1028 to the power of 0.25, which is the same as a quarter, we get a different number, 0.25. Different number. 28 to the power of 0.25, and we get the same answer up here. So bad, so good. No. So this one you must know. You must know this. Any number, no matter how crazy, except for 0, when raised to the power of 0 equals 1. So 32986.418728 to the power of 0 equals 1. 0 to the power of 0 does not equal 1. You should get, if you put it in your calculator, math error, syntax error, does not compute. No such number. No such zone. So without much ado, let's jump in and solve these ones. So this one here, we are multiplying 5 to the 3 times 5 to the 4, dividing by 5 to the 2. Well, the base doesn't change. 3 plus 4 minus 2 is 5. And that's going to be 5 to the power of 5. 3,125. All right, this one here. So we subtract the exponents of like terms into the final equation. So 7 minus 2 is x to the power of 5, and the x's go. X cubed over x to the power of 1 is y squared, and that goes to 1. So our answer is x5, y2. Fair enough. Okay, when we multiply these two together, all right, let's do some examples. Hopefully you can hear me. I've been having a little bit of trouble with my microphone today, so you don't really want to hear me, to be honest. Okay, let's evaluate these. So 27 to the power of 2/3. So we know it's going to be the cube root of 27 all squared. Well, we know that the cube root of 27 is 3. Because 3 times 3 times 3 equals 27. And then we want to square that, and we get 9. And let's grab our calculators just to make doubly sure. So 27 to the power of 1 over Right. 2 over 3 is 9. So far, so good. All right, 16 to the power of negative a quarter. Ooh. Right, well, how are we going to do that? Well, it's negative 1, so it's going to be 16 to the power of negative 1. And then it's going to be the 4th root of that. Are we into bad territory here? And the answer is no. So 16 to the power of negative 1 is 1 over 16. Now, finding the 4th root, we're going to raise this to 1 over 4. And we get half. One over 2. How about that? All right. X to the 3 over 2 times x to the half, the same base. So 3.5 plus 1/2 is what? 4 over 2, which is 2. So therefore this is equal to x squared. This one is going to be really, really quick to answer. This is equal 1. 4 to the power of 2 over 4 to the power of 2. Well, it's anything divided by itself except for 0 is 1. I guess you could say 4 to the power of 2 over 4 to the power of 2 is equal to 4 to the power of 2 minus 2, which is 0, which is 4 to the power of 0, which is 1. Okay, combine the exponent rule with another rule to simplify. Okay, well, let's deal with this first. Z to the power of 3 to the power of 0 equals Z to the power of 0, which is 1. 1 times that equals that. That's that. That's all there is. This one's going to need a little bit of work. Let's expand out these brackets here first. So this is the bracket that's on top. And we want to square all of that. So it's going to be 4, the coefficient has to be squared first. X, now when we're raising it to a power, we multiply x to the power of 6. Y minus 2 times 2 is minus 4. Okay, then we go to times that by x minus 1, y 4. So 4 comes across. The x loses 1 to make it x to the 5. The y has negative 4 and there's plus 4. So it's y to the pile of 0, here, and I'm going to leave it as y equals to the power of 0 there. It is 1, I know. But let's expand out the bottom bracket to see what we get. X squared y negative 3 all cubed. There's no coefficient, so it's going to be x to the power of 6 y to the power of minus 9. So when we put this thing over this thing, we get 4 x to the power of 5 y to the power of 0 x to the power of 6 y to the power of negative 9. So what needs to come through? The 4 can stay where it is because there's just a 1 there. The 5 minus 6 is a minus 1, so I'm going to keep that x down the bottom. And the y is 0. I'm going to put the y at the top, and we're done. It's a 9. It's not a Q, by the way. I'll rub that out. It's a 9. Yeah, that makes sense. Okay. I think that's the last question. I'm running out of steam pretty quickly. Solve the following equations. 2 to the power of x plus 1 equals 116. Okay, well 1 over 16 is the same as 1 over 2 to the 4th, which 1 over 16 1 over 16 must be 2 to the power of minus 4. Okay, so 2 to the power of x plus 1 equals 2 to the power of minus 4. That's what 1 over 16 is. And remember, when a to the m equals a to the n, m must equal n. So x plus 1 must equal negative 4. X must equal negative 3. Okay. We need a good base for this. So this one, let's make them both base 3. So 9 is 3 squared. 27 is 3 cubed. So therefore 9 to the power of x must be 3 squared to the power of x is 3 2x. Yep. And this one here now is going to be 3 to the power of 3 so I'm going to multiply all of that. 3 to the power of 3x minus 3. I just expanded all of that out. So we have two things equal to each other. They have the same base. I'm going to rewrite them down here. There's a little bit of space. So 3 to the power of 2x equals 3 to the 3x minus 3. And again, situation here counts. So 2x must be equal to 3x minus 3. I'm going to add 3 to that side and take 2x away. So x equals 3. And we're done. That was a good little recap.